Hey, what's up, y'all? So I'm back with another Road to CCNA video. And in this lesson, we covered LAN architectures or local area network architectures. Now, throughout this course, we learn almost everything there is about networks, at least on a basic level, when it comes to like routing, switching, security, access control lists. So now we're learning more about network design, and starting off, we learned about some common terminologies when it comes to network design, like the star topology, which is basically when you have one central device and all these hosts are connected to it. We learned about the mesh topology. Mesh is basically when every node is connected to each other. This offers like a lot of redundancy. And we also went over the partial mesh, which has less redundancy than the full mesh, but more redundancy than the star topology. So we'll have like some nodes connected to each other, but not every single node is connected to one another. Now from there we went into different network design, starting with the two-tier network design. This consists of an access layer and a distribution layer, or a collapsed core layer is also what they call it. But at the access layer, you'll have all your in-hosts, basically like your PCs, your servers. These connect to the switches. And at the switches, of course, you'll have like STP configured. You can also configure port security. Quality of service takes place here. Also, VLAN segmentation takes place here, and this all feeds into the distribution layer, or the collapsed core layer. Now, at the collapsed core layer, this is basically like the bridge from the bridge in between layer 2 and layer 3. So here you'll have like inter VLAN routing. You'll have some multi-layer switches there. You could even have routing protocols configured there, like OSPF. And this serves as the default gateway that gets you out to the public internet. Now from there we went on to learn about a three-tier LAN design. And three-tier has everything that two-tier has, but on top of that they have a core layer, which serves as the backbone of this design. So up here you'll find like your very high quality multi-layer switches, and it's all about speed, not policy up here. So just fast, reliable transport across the LAN. Now, we also covered the spine leaf architecture. Now, the spine leaf architecture, this is very common in data centers. This is a two-tier LAN design, but instead of data traveling north-south, it's traveling east-west. And so what we have is we have all our leaves, which consists of layer 2 switches. The in-host will connect to those leaves, and every leaf connects to every spine. And at the spine section, you'll have your multi-layer switches. So every spine will connect to every leaf, and every leaf will connect to every spine. But the leaves will never connect to each other, and the spines will never connect to each other. Now, last but not least, we cover SOHO, or small office home office networks. And this is basically anyone. If you have internet at the house, it's probably this. That's when you have one device that serves as your router, your switch, your firewall, all that, etc. It's very small network, so you don't need a lot of devices and a lot of extra stuff to, for it to function. So, yeah. Hey, what's up, y'all? So we do have a lab for today. I just finished it. I had to go back and like do some research on first hop redundancy protocols, just a little review. So I'll just explain everything that I did. So right here we have a two-tier LAN design, our distribution layer right here, our multi-layer switches. And down here, our access layer, where we have our regular switches, and our in-host right here connecting to the access switches. As you can see, we got STP running right here. This port right here, I'm assuming is in a backup state because it's not forwarding. Yeah, so step 1, we had to configure our first hop redundancy protocol, HSRP, on both of the multi-layer switches and ensure synchronization with STP. So in VLAN 10, they wanted multi-layer switch 1 to be the active router and the root bridge for STP. And then they wanted the second multi-layer switch to be the standby and the secondary root. Now, how did I do this? Well, first I had to check and see, do my, my little reconnaissance. And I looked up basically the standby information. That is the information that's going to tell us like what's the active router, what's the backup router, and the spanning tree information. And that's going to tell us who the root bridge is. Now, if I remember correctly, this switch right here, this one was not the root bridge for VLAN 10. So the way it goes is in spanning tree, when they select the root bridge is selected by the bridge priority. And if the bridge priority is a tie, then it goes on with the MAC address. And the bridge priority and the MAC address make up the bridge ID. So really, it's the lowest bridge ID wins. So to make sure, I just set this bridge priority lower than that one. So that became the root bridge for VLAN 10. And then for HSRP, the active router is chosen by the higher priority, if I'm not mistaken, router ID. Um, yeah, higher priority. So yeah, like I said, spanning tree, lower bridge ID wins, but in HSRP, the higher priority wins. So I set the priority higher on VLAN 10, but on VLAN 20, I set it lower. And then I went and did the same thing on VLAN 20, but opposite. So I set the bridge ID for VLAN 20 on switch 2 or multi-layer switch 2 lower than the one on switch 1. That makes it the root bridge for VLAN 20. And then for HSRP on VLAN 20, I set the priority higher than the switch on the first switch. And then to finish everything off, I did the little show commands just to make sure I had did everything right. But as you can see, for spanning tree VLAN 10, it is not the root bridge, but for VLAN 20, it is the root bridge. And then if we show standby, where is it at? Show standby brief right here. It is the standby router for VLAN 10, and it is the active router for VLAN 20. Yeah, to sum up this lab, man, we basically, for each VLAN, the switch that's acting as the default gateway is also the spanning tree root bridge. And this is better for data to just flow straight up instead of hitting like a blocked spanning tree port. And yeah, man, this was a pretty good lab, real network design right here. So I appreciate y'all for checking in.